Hi, welcome back. Let's look at example 4 of our rectangle's properties. Quadrilateral WXYZ is a rectangle with diagonals intersecting at V if the measure of angle XWY equals x plus 3 and the measure of angle YWZ equals x plus 15. Find the measure of angle XWY. First thing we should do is draw that quadrilateral, which we know is a rectangle. So I'm going to draw my rectangle. And remember, you can pick any corner to put W in, but then you either have to go counterclockwise or clockwise or counterclockwise as you name it. So WX, I cannot put the Y over here because I can't go across my figure. I have to put the Y along the edge, Y and then Z. My diagonals are intersecting at V. Okay, the measure of angle XWY equals x plus 3. XWY equals x plus 3. And the measure of angle YWZ equals x plus 15. YWZ, YWZ is x plus 15. Okay, remember in the last video we did look at a really long rectangle to illustrate to the fact that those two angles in the corner are not necessarily bisected, right? They are not necessarily congruent to each other. So I can't say that those two angles equal each other, but I do know since they're in the same corner, I do know that together they must make a right angle. Right? I have a right angle right here. So I know that if I add those two angles together, the red one and the blue one, they are complementary, they will add up to 90. So the measure of angle XWY, which is x plus 3, and the measure of angle YWZ, which is x plus 15. I know together they are complementary. So if I add these two together, I know they're going to make the corner, which is 90 degrees. So now I'm going to combine my like terms. X plus x is 2x equals 15 plus 3 is, or sorry, not equals, plus 3 plus 15 is 18, and that equals 90. All right, we'll subtract 18 on both sides. So I'll end up with 2x equals 90 minus 18 is going to be 72. Divide both sides by 2. And x equals 36. Okay, is that what I'm trying to find? I'm trying to find XWY. So XWY is that first red angle, is what I'm trying to find. So the measure of angle XWY we know is x plus 3, and now we know that x is 36. And 36 plus 3 is 39. So that angle is 39 degrees. Let's check our work though and make sure. My other angle, the measure of angle the measure of angle YWZ equals x plus 15. And I know that x is 36. So when I add those together, that's going to be 11 carry the 1, 51 degrees. And then just to check, I know these two angles together should make 90, and they do. So I can feel confident that that angle they were looking for really is 39 degrees. Okay? All right, let's look at number 5, example 5. All right, for example 5, quadrilateral CDEF is a rectangle with diagonals intersecting at G. If DG equals 7x minus 2 and CE equals 12x plus 6, find DF. So first thing I'm going to do is sketch that picture. I've got a rectangle, CDEF. I'm going to start in one corner and go clockwise around. You could go counterclockwise as long as you don't zigzag. CDEF. My diagonals intersect at G. DG equals 7x minus 2. DG is 7x minus 2. And that is half of a diagonal. (7x minus 2). CE is 12x plus 6. CE is a whole diagonal. This whole diagonal is 12x plus 6. Okay, so CE is a whole diagonal. All right, so now I need to figure out what I'm going to do with these, because these aren't going to be equal to each other, right? Because that's not going to equal the whole diagonal. It's a half a diagonal. And it's not angles, so they're not going to make 90 degrees, so I'm not going to add them together to make 90. But I do know that since my diagonals are equal and I know they're all bisected, I know that all 4 of these pieces are equal to each other. So when I look at this piece here, it takes 2 of those to make this whole diagonal. So if I do 2 of these, it's going to equal this whole diagonal. Okay, so how I'm going to write that is I'm going to say if I take 2 of those half diagonals, so 2 DGs, 2 of the half diagonals is going to equal a whole diagonal. Okay, so let's fill that in. Let's just substitute in. 2 times DG, 7x minus 2, is going to equal the whole diagonal, 12x plus 6. All right, so let's go ahead and distribute, right? That's the first thing I need to do is I need to distribute and double my DG. So when I do that, I'm going to end up with 14x minus 4 equals 12x plus 6. Let's get all our x's on the same side. So I'm going to subtract the 12x because I like to try to keep my x's positive when I can. When I do that, I'm going to be left with 2x minus 4 equals 0 plus 6. I'm going to add 4 to both sides. I'm running out of space here. 2x equals 10. Divide both sides by 2. And 1x equals 5. Now, is that what I was trying to find? I'm trying to find DF, which isn't even one of my equations. DF is the whole diagonal. But since I know my 2 diagonals are equal to each other, right, I can find the pink diagonal, and that should be equal to the blue diagonal. Or I know this green piece is half of the blue diagonal, so I could find the green piece and double it to find the whole thing. So let's try that. Let's say I know it's going to take 2 DGs to make this whole blue diagonal. 2 DGs will make the whole diagonal. 7 times x minus 2. Oops, and there's 2 of those. So that's going to be 2. And then 7 times, let's see, 7 times x. X we found to be 5. So 7 times 5 is 35. Minus 2. So that's going to be 2 times 33, which is 66. So that should be my answer. Let's see if we get the same thing when we do the pink diagonal. Okay, so when I look at my pink diagonal, CE is going to be 12 times x plus 6. X is 5. 12 times 5 is 60 plus 6 is also 66. So my pink diagonal is 66. Half of my blue diagonal, the green, was 33. So which one I double it is 66. So I do know that that whole blue diagonal, DF, is 66 units. And I could do it either one of these two ways. Okay? Again, if you have any questions, make sure you're asking your teacher during sync time. All right? In the next video, we're going to look at what it means to solve a picture, to solve a rectangle. When you're solving something, you find every single angle and every single side. So in the last video, we'll look at doing that. All right? Thank you so much for watching.